Hey YouTube, it's JB Dillon. Welcome to part 2 of the 1974 AS128e RCA solid state black and white television. In the previous video we tested the CRT, which tested like new. We powered up after cleaning a couple pots, making some adjustments and resoldering, and found that there is a terrible non-linearity and an overall lack of height and width. So that tends to point in the direction of the power supply. So I did get me a SAMS for it, and we're going to tear into it and see if we can figure out what's causing the lack of width and height, which I'm pretty much guessing is going to be low B voltage, but until we get inside and check it, we don't really know. So let's get the schematic diagram and take a look at how the power supply works. Okay, so here's our unregulated and our regulated power supply. And this is kind of a weird way of doing it. What they have is they have your transformer, which comes in, goes to your rectifier bridge. Your center tap is going through a capacitor to ground, which is kind of weird. Not sure why they're doing that. And the ground is 8.2 ohms, 7 watts. And the regulator here actually looks like it's the power switch. Because what you do here is when you hit the power switch, this conducts and pulls the low side down. At least that's the theory. And it's supposed to help provide 12 volts of power there. There's our 12 volt source A. So we need to check all the voltages in the regulator here and see if we're actually putting out 12 volts, which is going to be on pin 1 of the MA0002A module, which if we take a look here on the diagram, let's see, here it is. So this is the this is the module here, the 12-pin module that stands up, which is going to be that guy there. And it looks like they got some test points there, so that's good. There's your plus 12 test point. And the regulator is in fact marked. That's this guy here, so we need to check the voltages. And the collector is referenced to ground, it looks like. So the case of this thing should be grounded to the chassis. Well, I suppose we could take a look back here and make sure that it's, oh yeah, that's just grounded straight to the chassis there through that screw. So that is in fact chassis ground. So the weird voltages I was getting earlier, that could be part of it. Now let's look at potential points of failure. Just take a look at this thing. I don't think the regulator is bad, because obviously we wouldn't have much of anything. We'd have either no voltage or unregulated voltage. If it was shorted, you'd have unregulated voltage. If it was open, we'd have none. So there's the error amp there, which basically establishes the reference for the regulator driver. So let's see here. We could have the 2.2 microfarad capacitor. If that goes bad, like leaky or shorts, would pull down the error amp voltage, which would then pull down the regulator driver voltage, etc. We could have a defective or high 100 ohm 1 watt resistor that would have gone up in value, which would change the collector voltage on the regulator driver. We could have a bad Zener diode, which would change the voltage there. Sorry for moving around. I don't have a tripod for this thing. I think we're going to pull the card out first and check any obvious signs of failure, and then we'll pop it back in and do some troubleshooting that way. So this is the power supply module. It also does a couple of other things. But yeah, there's our 2 microfarad capacitor. There's all these resistors which could go up in value. There's a tantalum capacitor C10. What does that do? Let's see, I'm trying to locate it here. Where's C10? What does C10 do? It could be another part of the board that's not part of the regulated supply, because I don't see it depicted here. You've got the main filter, the 5000 microfarad. The big 7 watt 8.2 ohm resistor could have gone up in value. That would be this guy right here. Doesn't look particularly toasty or burnt. So let's just briefly test some components on here and just look for the obvious. Okay, so here we are with our infamous cap wizard. See if this tantalum's any good. Appears to be. We'll flip this over and test the little 2.2 microfarad. That still tests decent. Doesn't mean it isn't leaky, but there's a good chance that that's okay. We're going to check a number of these resistors and see if any of them are out of kilter. And then we'll plug it in and we'll do some live testing and see where our deficiencies are. Now, I don't think, we haven't looked at the schematic yet, but I don't think that this has any strange sweep-derived voltages. I don't think it's that complicated. But we are going to check the, there's our 100 ohm, 1 watt, still right on the money. What's that, a 5.6? Looks like a 5, yep, 5.6K reading 4.1 is probably fine. 3.9 reading 3.3. 470 ohm reading 526. That could be a point of concern there. You are R19, and R19 establishes the base voltage for the error amp, which we looked at earlier. So that is kind of an important part there. Let me place a little mark on this. Yeah, let's see here. This should be a 22 ohm jobber, 220 ohm, another 220 ohm. Interesting. That reads 5.4K. What's that supposed to be? That looks like a brown, red, orange. So that should be a 12K. Right? Alright, so 5K for a 12K is probably alright, since it is in circuit. Here's a 1K. There's a 22K. Reading 26, that's probably not going to piss it off. I can replace it anyways. That looks like it's connected to the base of Q1, which is, that can't be Q1. Q1's the regulator transistor. They mislabeled that here. Anyway, it's connected to the base of this transistor, but given the fact that that's only gone up a little bit, I don't think that that's too big of a deal. That should be 88.82K right there. Reads 97. That's a little high. So maybe we'll put a mark on this guy too. These drift-o-matic carbon resistors are great, aren't they? And then let's see, we got underneath here, that looks like a 47 ohm or 470. Really? Oh, there's the yellow band there. No? There's something wrong about that. It's yellow, purple, brown. That would, I would think, be a... Let's see, what does this one read out as? This one's R what? R8? Looked at the schematic there. Trying to find this damn thing. It says it's R8. Must be another section of the board. Where does it go to? R8 along with R4 feed the cathode of CR1, it looks like. Yeah, let's take a look at that. Of course, you wonder how much of this is correct based on, sometimes you'll see SAMs with incorrect nomenclature. But if that's correct, let's see, there's your Zener diode there. They listed as VR1 here, it's CR1 on the board. There's supposed to be a 330 ohm going to it. And then there's a variable 5.6K. I don't see that anywhere here, so maybe we have an error on the board. All I'm doing is looking at that. And so like there's a, what looks like a 3.3K. Well, that reads correct. And then this here should be like a 10K. Yep, it measures 11. That should be like a 33. Measures 39. It's a little high. And then this guy here, 52. But this one right here, I don't know if you can see that, but I see a yellow, a purple, a brown, and a silver. So I would think 470 ohms, right? Oh, there we go. I'm just looking at the wrong decimal place. So it's 553 ohms. So it's a little high, but it's not. Yeah. Wake up. Wake up. We're going to put a mark on that one too. But I don't know where this V voltage adjustment is that they're talking about. Maybe it's off the board. They call that VR1. But it says it's on the module. I'm just not seeing it. Unless it's been substituted with something else and there's just some revision change I'm unaware of. But let's go back to looking at this. 5.6 reading 6.1. So a lot of these carbon resistors are really kind of out. Like here's a 56 that's reading 69. That's got to go for sure. And what are you? You're a 51K, it looks like. A lot of these, yeah, that's more than 10% out. So a lot of these carbon resistors, man, they're just terrible. I think I already checked these guys here. Oh no, there's your VR1. $27 measuring 32, 330. Yeah, that one's okay. 348, that'll do. 120 measuring 138. I mean, they're all way out. And when you're looking at a regulated power supply, it's pretty important that that stuff all be there and working properly. So I think what I want to do is I want to change these way out of tolerant resistors and kind of bring the system back in here. This is interesting how they have this on standoffs. Not sure what R12 is supposed to do here. And there are some things on this schematic you don't see. Because part of this, I think part of this is the regulator and part of this is the vertical. Because, let me just switch positions here. See, the other part is the MA0002A, which is also the vertical in the sink. So there's stuff there. There's two things on each module. See, same number module. Same number module. So this module has two purposes. We've got vertical and power supply. So that's interesting. But I'm still confused as to why we don't have an adjustment potentiometer there for R13. Where is R13? I see R12 that they've got a fixed position on. 5, 6, 7, 18, 11, 12. Yeah, where is it? Sometimes you can see it on the back of the board here too. I am just not seeing it. See, there's R13. There we go. They've got a fixed resistor there. Of course, maybe I'm an idiot and that's just a piece of chicken scratch. Yep, that's a piece of chicken scratch. See, I'm not seeing things right today. I thought that was a variable. Okay, well, at any rate, let me change these resistors out that are like way off, and then we'll get this thing popped back into the set and see if that makes it behave a little better. Alright, so I've replaced the grossly out of tolerance resistors in the regulator and vertical section here. And I had to fudge the 51K because I didn't really have a 51K, but now we're going to pop this thing in and see, check our voltages and stuff and see how it's operating now. And hopefully that will fix it. If not, then we have to do some more troubleshooting. Okay, let's see how she looks now. Oh, it's got instant on. Well, you can see we didn't really change much. We still got this shrunken raster here with this terrible linearity problem. And as I recall, I couldn't turn the vertical up any higher. I think that was all she wrote. Yeah, see, that's my vertical maxed out right there. Not really adjustable vertical hold. That's at one extreme, and then that's at the other extreme. So let's poke around on that power supply board and see what we can come up with there. And yes, I am aware that my batteries and my meter need to be changed. 11.2 volts, that's pretty damn close to 12. $25. Let's go ahead and short it out. Minus 5.6 out of 6 is pretty good. Interesting. Not much going on there. And then let's look on our regulator, because the regulator has some weird voltage measurements here. The collector is supposed to be grounded, of course, which we got going on here. Ooh, what was that? Flicker, flicker. I touched something, I didn't like it. Alright, the base is supposed to be minus 3 volts, and the emitter is supposed to be minus 4 volts. So if we look on L base, we have minus 5.6 volts on the base of this big thing. That's too high. Something's wrong. And then on the emitter, I have minus 6.3 volts. So this is definitely not conducting enough, which would explain why our voltages are wrong. So base is way too high. Base is supposed to be minus 3 and it's minus 5.6, and the emitter is supposed to be minus 4 and it's minus 6.3, so it's all really high. And that's going to change the low point and affect the completion of the circuit. It's a weird regulation design, but that's just how they do it. So we need to look at the reasons why that voltage would be high, because that ain't right. So I was seeing 5.6 volts negative on pin 6, which comes off of that regulator driver transistor. And then we have the error amp, which is supposed to be doing all that mess. Pin 2 is supposed to be grounded. But all that on that card's going to be fairly inaccessible there. So if the 5.6 volt isn't regulating downward enough, how does that affect that? Where is the negative voltage derived from? See, we got 6 on the collector there, minus 4 on the base. How is that derived from? And then minus 3 on the emitter, which obviously ain't getting to there. The voltages are way too high. And it's hard to say. I guess that's supposed to be negative there. Or is it? Is this another one of those silly mess ups? Because that looks negative, but it's hard to tell. And how would you have a negative voltage? Oh, I see. So we're taking the low side, the center tap there, through the 5,000 microfarad capacitor, which then goes down to the emitter, which in theory should be negative. And you got that 8.2 ohm resistor. Yeah, this thing's been on a while. It's not widening up. It's not getting any better. Now, if the 8.2 ohm resistor goes high, then that would definitely increase the voltage there. But you would think that the base would be able to regulate it. It's 2 volts higher than it's supposed to be. So I don't know. Let's check out the 8.2 ohm resistor first. Yeah, so we got pretty close to 8 ohms here. I don't think this is the issue at hand. And it's changing because there's a little bit of voltage bleed from one of the caps on it. But if I short it, the point to ground, and then remeasure, it comes up 8.3 ohms. So that resistor ain't it. So really, we have our regulator driver, and the voltages at that driver are incorrect. So the driver itself could be a problem, or a support component could. Now, we have that Zener diode there, which is supposed to regulate exactly 4.5 volts negative here, which then goes to 4.63 negative there. And then we're supposed to have 6 volts at the top of Q6 at the collector side. So pin 1 should have slightly higher than 6 volts, at least that's what we would assume. Because down here you'd have 5.6 regulated through the 330 ohm resistor in the Zener. And as far as I know, those resistors there were within spec. Of course, let's go back to VR1 and look at the 330 ohm. If the resistance goes up too high on that, then that wouldn't provide enough voltage to allow the Zener to regulate. Yeah, 349 ohms, that's, you know, a 20 ohm difference. It's not enough to piss off that circuit. So Q7 is the error amp, which is over here, and then Q6 is the driver, which is here. So these both need to be pulled and checked for leakage and proper gain. I think one of those two is going to be our issue. Okay, so first we're going to check our big guy. We're going to see what the rest of the world believes this thing is. It says it's a diode. Yeah, I don't know about that. There we go, NPN beta 251. Okay, so that seems pretty happy. Let's take a look at the error amp here. It's supposed to establish our reference voltage. If it'll cooperate. I think I just may have to use the little thingamachigas. That's a PNP beta 173. So nominally these are functioning transistors. Let's check them for leakage. So let's first do this guy. We're going to go between collector and emitter. That's very leaky. Yep. All right. So we have like massive leakage on this device. No bueno. Let's check the little driver guy. And again, I like this WB519 because it puts about 22.5 volts across the device. No leakage in that direction. Of course, you aren't doing much at all here. Maybe you're defective. Maybe we had a massive regulator failure. Oh, no, there we go. Okay, so it's good in that direction. You should get nothing in this direction. Okay, so the main driver for the series pass regulator, or actually it's just a voltage regulator, this guy is horribly leaky. So we need to figure out what he is and what the characteristics are and get a replacement in there. Because that's why it ain't regulating right, and that's probably why we got a lack of voltage. Even though I got almost 12 volts, but something else is off because it obviously is not working right. It looks like Q6 is a GE27 SK3104 ECG 171. So let's check out what an ECG 171 is. Well, NTE 171 is a 300 volt 5 amp. Wow, 50 watt, that's a big boy. No, that can't be it. Looking in the wrong column. Alright, it's a 10 watt, half an amp, 75 megahertz, 40 gain minimum, easy peasy. Like a 2SC 4793 would be good for that. A little bit faster than what it's looking at, but that should work. Let's pop one of those in there and see what happens. Alright, so there's our new regulator transistor install. Let's pop it in and see if that has any effect on it. No worky? Plug just wasn't seated right. Still got the crummy Yep, still crummy. And what's our voltages look like? Still crummy. I still have the -6 and -5 here. So something in that regulator circuit's still wrong. So far I'm kind of spinning my wheels on this one. I replaced the series pass regulator, 5.6 volt Zener, all that sort of thing to try to get the 12 volts stabilized. But I'll tell you something, if we take a 12 volt supply, which I have over there, and we go right to the 12 volt source here, and we watch this thing power up, all the problems with it are gone. Look at that. Full raster and all that sort of thing. So it's definitely a power supply issue. Just need to figure out what's causing it and why, because that works great. If I supply an outboard 12 volts to it, it's perfect. But if I try to use the internal one on the machine, let's just plug this back in here, it looks like garbage. We got a dim raster where you can see the non-linearity there, which is wrong. And if we come back over here to the power supply and take a look at what's here, it says 11.5 something or 11.1 something volts, which I guess is a little low. So let's Not a lot of ripple there. Just needs more oomph. It's not like there's ripple, bad capacitors or something pulling it down, but the internal power supply just isn't working. And I'm concerned that there's some other component I'm simply missing. Something, it's not a load thing because the outboard power supply just does it. So yeah, I'm not sure here. Yeah, that messes with things, that big 8 ohm resistor. So I'm still scratching my head over this one. It's definitely a power supply related issue, because if I supply outboard voltage from another supply, it works perfect. So yep, this one's a tricky one. So when I use the outboard supply, which coincidentally is cranking out 13 volts, this thing behaves absolutely normal. We got good deflection, good linearity, everything's cool. When we go to the internal, instead of getting 12 volts here, I'm only getting 11.1. That may not seem like much, but if the whole thing runs on 12 volts, more than 11 volts, that's more than 10% drop. So that is going to tick it off. So what we've done so far, the regulator driver Q6 was defective. I replaced that. It was very leaky. Q7 seems to be okay. The Q1, the regulator, I changed out. It tested a little leaky, but that didn't solve anything. And that's kind of where we're at. I replaced a lot of out of tolerance resistors that had gone way up in value, but that really only changed things marginally. But really, what I find is I have to generate that 12 volts or greater, probably closer to 13, in order to get that happy. So how do they get 12 volts here when you've got 5.6 as a regulator? Of course, that's your error amp. So where does the 12 volts come from originally? So the 12 volts is supposed to come from the transformer through the rectifiers. Minus 15 volts there. Like, what's going wrong here? I'm not really sure. This is the way that they're regulating this is definitely different. Yeah, I'm not sure. I'm really spinning my wheels here. I have higher voltages than normal on the regulator device. Got minus 6 on the emitter and minus 5 on the base. I mean, it's still a volt across it, so it should, in theory, not make any difference. But we're just not seeing that 12 volts there. And if I feed 12 volts directly in, it works fine. So, yep, still scratching my head over this one, but I'll figure it out. Well, she's looking good now, but I had to toy around with it a little bit. What it came down to was no matter what I did as far as checking component values and stuff, this was all spot on. But it wasn't regulating properly. I was having too high a voltage here. It was like, minus 6 and then, minus 4.4 or something like that. And then that would go out to here. Actually, it was actually closer to 7 up top. And then I'd have minus 5 here, which would show up on the emitter here as minus 6 and then minus 5 on the base. So the supply voltage that comes in from the transformer is minus 15 volts. And then they have this weird center tap doubler circuit, which when you control the low end of that doubler circuit, is supposed to end up with about 12 volts usable. And I was only coming up with 11.1, which was giving me that shrunken raster and all sorts of nasty stuff. So what I ended up having to do was I changed the voltage divider here. I upped this to 220 ohms to increase the collector voltage to about 6.5 volts And then I changed the zener from 5.6 to 6.2, which gave it a little more feedback and backed off on the voltages here, so that I was only showing up with about 4.1 volts here and about 3.2 volts here. So that's pretty damn close. So now I show up, instead of -3 here, I got -3.2, and I've got -4.6, and it ends up being about 12.2 volts, which is about as close as I'm going to get with this thing, and it's now got proper B voltage and good horizontal linearity. We're still maxed out on our height though. That's at maximum height, so we need to address some problems in the vertical still. But she's running, and she's running with the right B voltage, so that's going to conclude this section. So next we'll work on the vertical sweep, or the lack thereof, and some other ailments that this thing has. But anyways, thanks for watching part 2. More stuff to come.